So looking at quartiles, if we want to look at a more detailed description of how the data is spread out, then we look at different sections. We divide it into small bits. Percentiles you probably would have heard of. That's when you get crazy and you divide it into 100 parts. Okay, so the score in the 90th percentile means 90% of the scores were less than yours, and so on. Deciles do it in 10 parts, but what we're interested in looking at right now is quartiles, where we divide it up into 4 parts, so groups of 25%. So the first quartile, Q1, so it's known as the lower quartile. It could also be called the 25th percentile. So it's basically 25%. Then you have the second quartile. Now Q2 is the median because it's going to be the middle of the data. Third quartile then is Q3, and that breaks into the upper quartile, which could be the 75th percentile because better than 75% of the data. That brings us to this idea of interquartile range, which is usually a better measure than just the range itself, because the range itself goes from the highest to the lowest. Now, if you've got some outliers, things like that, it's not really telling you about the spread. But the interquartile range captures that middle 50% of data, and it gives you a better idea of the spread in a lot of the cases. So your lowest score is going to be over there. It'll go up to Q1, 25% of the data. Then it'll go up to Q2 or the median. There's the next 25% of the data. Then up to Q3. That interquartile range is that middle 50% going from Q1 to Q3. And then you have the top 25% there going from Q3 up to the highest score. So interquartile range, Q3 minus Q1. So how do you calculate it? So again, it's different depending on whether you've got odd number of scores or even number of scores, how you handle it. Say this is all our data. Again, you put it in ascending order. Now I've got an odd number of scores there. So in this case, I just omit the median. So Q2 is 5 in this case. And then that breaks it up into 2 sets of data. Q1 will be the median of the first set of data. And in this case, I've got 2 numbers. So I'm going to have to find the average. Well, the average of 2 and 2 is 2. So Q1 is 2. But then I do it to the right-hand side as well. And the average of 8 and 9 is 8.5. So the interquartile range for this one is 6.5. So that's if I have an odd number of scores. Now, if I have an even number of scores, so let's use this one. There is no actual median, but I can just simply split it into 2 halves. Well, Q1 will then be the median of the first section. In this case, I've got an odd number of scores, so it'll be 8. The right-hand side, we have 11. Interquartile range of 3. The median, of course, for this one would be 9.5. We average the 2 middle ones. That brings up this thing called a 5-number summary of the data. Basically, it's those 5 key things: the minimum mark, Q1, Q2 or the median, Q3 and the maximum mark. And so for the examples we just looked at, the first set of data, it would go 1, 2, 5, 8.5 and 10. And the second set of data, 6, 8, 9.5, 11 and 15. So they're our 5-number summaries. Now, you've probably seen these, but in a graphical way. And that's our box and whisker plots. Let's draw one in. 2 exams, and just say, not 2 exams, sorry, 1 exam, 2 classes. They did this test, there are the results. And I've put them in ascending order there to make life a little bit easier. If I was going to put them in a parallel box plot is just another name for box and whisker. And there they are. So class 1's the red one there, class 2 is the blue one. So when we're drawing these, your whiskers, lowest score and the highest score. The box is going from Q1 to Q3, and then we mark Q2 in the middle of the box. And it's a visual way of comparing the 2 data. Now, that brings this idea of outliers, because you'll notice in class 2, these first 2 marks, 23 and 37, it's really throwing out that whisker. So is it a fair comparison by including them? So when do we include them? When don't we include them? How do we know to exclude certain data? This is the common way of doing it. Basically, 1.5 times the interquartile range away from Q1 or Q3 if you're going the other way. If it's more than that, we'll say that's an outlier, not going to include it in my data set. again, if you're explaining this, you're presenting your data to someone, and if you're leaving out some scores, you would tell them that. You'd let them know there were outliers that have not been included in this data. If I don't include those two scores, look what happens to the box and whisker. Now, it still looks like the red one's better, but not by as much as first thought when you get rid of those outliers. Actually, you can see the whiskers there are a bit closer now. Well, certainly the bottom whisker anyway. Turns out, for class 1, the average was 82.1, the spread, or the deviation, 9.37. If we included the outliers, we got 72.1 with a spread of 17. But if we exclude them, the average comes up to 76.6, and you can see the spread comes in. It's only 10.48. So that's why we often exclude these outliers on the data. Okay, there we go. 15C.